Recently, we've received many questions about what size power cable should be used for high-power amplifiers. Some people are concerned that when the amplifier is working at high power, the power cable we use may not be able to handle the current, which could affect performance or even cause safety issues. So today, we're going to run a real test using the D18K4 amplifier and use actual measurements of voltage, current, and temperature to give you a clear answer. First, we use a current probe to measure the input current of the amplifier and a voltage probe to measure the output voltage. Now we turn the amplifier up to maximum level. At this point, we've completed the measurement setup. On the screen, the green waveform shows the output voltage. The purple waveform shows the input current. Let's begin with the first test, a sine wave signal. We use a sine wave because it creates the most demanding condition where the amplifier is working continuously at full load, like running at full speed without stopping. Now the output voltage has reached its maximum level, and we record this set of data as our reference. Next, we switch to a real music signal for measurement. Now we increase the signal level. As you can see, both the output voltage and the input current are constantly changing with the music. When the music gets louder, the input current increases. When the music becomes quieter, the input current drops significantly. So the amplifier is not working at a constant level. It's changing all the time depending on the signal. We record this set of data so we can compare it with the previous test. Now let's compare the results. The sine wave signal is continuous and constant, but the music signal is always changing. This clearly shows that when using a sine wave versus real music, the voltage and current behavior are very different. And because of this difference, the temperature inside the amplifier and in the power cable will also be significantly different. And this is why, in real-world use, a properly rated power cable can still operate safely and reliably without needing to be excessively thick. Finally, let's look at the temperature during the long-term test. After several hours of full load testing with music signal, the amplifier's external temperature stabilized at 41 degrees Celsius. The power cable temperature reached 38 degrees Celsius. Both are well below the safe temperature limits of the insulation materials. This shows that the power cable we selected is well matched to the amplifier's real operating conditions. It can handle short bursts of high current while maintaining safe temperatures for long-term use. So here's the key point. The power rating of the amplifier does not mean it is drawing that power continuously. In real applications, the current is constantly changing, and high current only appears for very short moments. That's why the system can operate safely with a properly designed power cable.